Hello. Today we're going to talk about reliability and validity, two very important concepts in statistics and, of course, in research methods. If you take a research methods class, probably you can spend like two, three, four classes talking about reliability and validity. In this course, we're simply going to touch some of the very basic concepts. So, what this lecture is all about, we're going to talk about basically cover what is reliability and what is validity, why they're so important, what are some of the different types of validity and reliability, and how do we interpret the reliability coefficients? Essentially, these are measures that they tell us if, in fact, our data is reliable and valid. So, quality research, you probably heard the term that you put garbage in, garbage comes out. And what do we mean by that in research is like, yeah, it is very easy to collect data, any type of data, but not all type of data will produce quality research. So there's a lot that goes into quality research projects. First of all, it starts with methodology. A researcher needs to thoroughly read previous research. He needs to be aware of what has been done so far and what is still lacking in the field, or maybe possibly there are certain things that they can be added into the existing knowledge. So he first of all needs to be very well read. Then he needs to be aware of all the various theories that relate to that particular field. After he decides on a particular theory or framework that he's going to use, he needs to look, of course, at his budget because a really good quality research project costs a lot of money, and then figure out the best possible way to conduct his research given his budget, his time, because time is also essential. Some research projects can take several years. Some of them can be as quick as probably 6 months would be the quickest research project, and probably is not going to be a very quality project. So there's a lot of decisions that you need to take in mind. Then beyond that, you have to think, okay, well, how am I going to collect data? Am I going to have a survey? Am I going to have interviews? How am I going to create the questions? What type of questions am I going to ask? Who are going to be my participants? And how do I need to phrase my questions so all my participants understand the question that I'm posing to them so they don't respond inappropriately? So putting a research project together is a lot of work, and it actually takes a lot of minds and a lot of trial and error. So let's go back to what is a dependent and an independent variable, okay? So I'm putting here a word that is underlined cause and effect, okay? I know in psychology it's a horrible thing to say that something is causing something because apparently there's a lot of things that take into effect, and causality is something that we need to be very cautious about every time we use that word. But in our case, it's very easy way to separate and essentially remember what is an independent variable and what is a dependent variable. So the independent variable is what the researcher manipulates. So this is what you're changing, and you're hoping you're going to see an outcome because you're changing that independent variable. So essentially we can call it a cause, although it's not a cause, but maybe if you think it on these terms, right? So the independent variable will be what will eventually cause your effect, and your effect is going to be your dependent variable. So that is your final outcome of your research project. In our example here, so if you look at the picture, we having a young boy and he's eating M&Ms. So we can say that candy eating and cavities. So candy itself can be the independent variable, and if you get cavities from eating candy, that would be your dependent variable. Now, when it comes to causality, so if you go back to your previous chapter, Pearson's correlation, right, we said that an association, a correlation does not equal causation. And the reason that we say that, think about it. When can somebody actually eat a lot of candy but not get cavities? Is that possible? Absolutely. Maybe they brush their teeth right afterwards, right? Or they have really good hygiene. They floss, they go to the dentist very often. So there is possible that somebody is eating candy and not eating cavities. So essentially, if we run a research project and maybe our participants happen to have very poor hygiene, we're going to see a very strong association between the two. Okay. Nevertheless, right, maybe Candido, it's not an indicator that promotes cavity. It is a risk factor, but hygiene also plays a role. So when we're thinking about what is going to be my dependent variable, we also have to think of everything else that can essentially interfere or affect our final results. Now, another thing that you need to be aware, because we're going to be talking a lot about error, is there is the observed score, there's a true score, and there is an error. Now you wonder, well, what is the difference? Let's just take an exam. So you're going to have an exam very soon, and you're going to get a score. Let's just say you scored 90% in the exam, and that is a great score. So the question is, does that 90 truly represent your knowledge in statistics? Maybe you happen to be very lucky that day. Maybe you happen to be feeling really amazing, or you happen to get questions that you really spent a lot of time studying. Okay, but maybe my exam was not capturing equally all the different chapters. So maybe your observed score is really high, but that not necessarily reflects your true score. Vice versa, maybe somebody studied really hard and for whatever reason they weren't feeling good that day and they didn't perform as well. So maybe they end up getting 85% in the exam, when in reality they're really strong students and they could have scored a lot higher, right, if they were feeling better. Okay, so apparently there's going to be a difference between the observed score, which is what somebody ends up getting. This is what we're observing, with the true score, which the true score reflects the true knowledge of somebody. So the discrepancy between the observed score and the true score, that is some kind of an error in there, something that essentially affecting someone's performance. The thing is that no matter how well you will design a test or how well you will prepare for it, right? There's always going to be things that they can interfere with your performance, okay, or how the actual test performs. Now, in statistics, the discrepancy between observed scores and true scores, right, is we call it an error score. So essentially, the observed score would be equal to your true score, your true knowledge, plus or minus, right, an error. So that error accounts for anything that can possibly go wrong during a test that essentially will affect your overall performance. In a case of a testing, maybe you walk into a room, right? The room is too hot, you start sweating, you cannot concentrate. Maybe somebody next to you starts kind of like making noise. Like I remember when I was taking my GREs, I had a person that was making a lot of noise on the desk. They were just like tapping their fingers on the keyboard and absolutely drove me insane. I was not able to concentrate. You know, thank God they had headphones. I was able to put my headphones and I was finally able to concentrate. But for sure, I lost time trying to figure out, okay, how can I block that noise because I was not able to perform the way it was. Or maybe you didn't sleep good the night before. Anything that essentially could perform your performance um, can become a barrier. So, in you to truly capturing your true score, that would capture your true knowledge. Also, into that, capturing your true knowledge also means that the test is very well designed. The questions are being asked in a way that you truly understand the question and you're able to give them your best answer based on your understanding. Because there's a possibility that the question is not well written, hence you didn't understand it well, thus you didn't essentially provide them with the correct response. Okay, and that is why actually that I tend to curve my exams. I always look for patterns. So once you guys submit your exams, I wait until everybody's done. And then I'm looking for any particular question that didn't perform well. So if I find a question that, say, 60% of my students did not get right, then I assume that there's something wrong with that question and I remove it from the test altogether and everybody gets credit. So Another example would be, why do we need reliability and validity every time we design research? It's really, really important, right? If we didn't have some kind of a theory that kind of like drives and establishes the framework from designing um, quality research, everybody would do whatever they want to. So let's just imagine just instructors, right? They walk into the class and they prepare a test. That measures your ability or your knowledge about the subject 5 minutes before they walk into the class, right? Most likely that would be a very poorly designed test and it wouldn't necessarily capture your knowledge on the subject matter. In this particular case, I'm giving you somebody's trying to measure your intelligence, right? So maybe the way they measure intelligence is by asking you very difficult questions that essentially requires a lot of reading. Maybe there's the majority of the questions is advanced math, and let's just say the majority of people fail. Well, does that necessarily means that people are not intelligent? No, that actually means that this is a very poorly designed test and is not capturing what is supposed to capture, and that is intelligence in this particular case. So when we design something, we want it to perform equally well no matter how often that test will use that test. So reliability over time. And at the same time, we want to be as accurate as possible. So, like in the previous example, if we want to measure an IQ test, we want to design an IQ test that accurately measures, okay, IQ. So we're going to probably have to consult with the experts what is the best way to identify, okay, ways of measuring IQ. We're going to have to read the theory and then come up with a set of questions that would capture that. So reliability, as the word implies, right? When you're reliable, you're trustworthy. I have a picture here with a guy sitting with a flat tire and he has a bunch of tires in his truck. Apparently you buy tires because you want to be able to drive your car for a period of time and you want your tires to be reliable. Likewise, when you design a test, you're hoping that test will perform very well over time, right? Over and over, will be able to capture what it's designed to capture and will always perform as well. So now reliability comes in different flavors. Okay, so we have retest, test, retest reliability. We have parallel forms reliability, internal consistency, and inter-rater reliability. So let's take it from the beginning and see what each one does. Test, retest reliability. Okay, so here the main goal is to check for stability. So we want to see if the test that we design performs the same way over time. So essentially, if I give you a test today and then I give you the same test 6 months from now, would you be testing as well as you did in the first time, right? So the idea is stability over time. So how do we essentially check for test retest reliability? We're using Pearson's correlation. So if you remember Pearson's correlation, it measures an association between two variables. So here you can actually take test number one and test number two and correlate your findings to see if they're similar by any means. And remember, when you're having two variables that essentially should be the same, you should be getting a pretty perfect straight line, direct correlation. Okay? Now, why would we want to have scores to be similar? Well, think about it. If you tested well the first time and then the second time that I'm testing you, you're not testing very well, that says something, okay? That says that this something is not working on the test, okay? Either content-wise or whatever that may be, is definitely is not a good sign. And it's telling the researcher that you need to go back to the drawing table. Parallel forms. So here, you are actually creating a survey, but in different forms. You probably had instructors that they gave you tests like such as test form A, test form B, test form C, simply because you were sitting very close to other students and they were trying to avoid you guys cheating from each other. The idea is that you will design three different tests that will capture essentially the same construct, but with different questions. The challenging part is how do you come up with questions that they will actually measure the same thing, but they will perform exactly the same way? I remember back then in the days when I was TAing, right? I was TAing for a class. I'm not going to name the class, but I noticed that people taking exam A, they were performing way higher than people who were actually getting exam B. I was very curious as to why is that? Why the students who were getting the exam B test lower than the students who were getting exam A. So looking a little bit further into it, I realized that they did indeed have different questions. And the instructor thought that the questions were of equal difficulty, yet apparently the results showed otherwise. Eventually, the instructor ended up changing the exam altogether, and me personally, as an instructor today, I realize that it's important to give all students the same questions. So when I'm afraid about cheating, and so what I will do is mix the questions and I will mix the choices, like the ABC choices in between them, but all my students will get the same question. This way I can ensure that regardless how many different forms I'm creating, all students are getting the same questions. Because to be honest with you, to create different questions that they measure exactly the same thing is a very, very difficult thing to do. Internal consistency, okay? So internal consistency is used when you want to know whether the items on your tests are consistent with one another in that they are all represent one and only one dimension or construct. Example, say you created a scale that measures aggression. You would want every question on your survey to measure aggression and nothing else. Crumpux alpha is a special measure of reliability known as internal consistency. The more consistent item scores vary with the total score on the test, the higher the value of the Crumpux alpha. We want a high value. Your alpha value needs to be positive, so in this particular case cannot be negative like the Pearson's correlation, so it has to vary from 0 to 1. The closer to 1 you are, the higher your internal consistency will be. Here you can see that I'm giving you the formula, but be aware I'm never going to have you calculate manually the Crumpux alpha. I'm just simply giving you the formula that you may probably use if you go to grad school. But for the most part, in our case, we're going to revisit this concept again, but we're going to use SPSS for it. Much easier, it's just a click of a button. So in SPSS, it's also inside your book. All you have to do is go under the Analyze menu. Remember that we're going to be using Analyze menu for the majority of analysis that we will performing with SPSS. You're going to find a menu called Scale, and under Scale, you're going to find another menu called Reliability Analysis. You're going to have a dialog box like you always do, and then you will be giving a choice to click the alpha to run the Crumpux alpha test, and then you simply click OK. So it's really easy to do. Again, your book has the exact instructions if you want to give it a try, but again, we're going to probably revisit Crumpux alpha later on when we move into the inferential statistics. Inter-rater reliability. Okay, so this is an interesting one and a very, very important one if you're dealing with a type of research where a lot of people are working or observing or interviewing participants. Okay, so for example, in psychology, a lot of times we use observational methods, right, to analyze phenomena or behavior. So you're sitting there with a coworker and you're both watching the same thing. The question is, are you both able to view this exact same thing? So apparently in front of you, you're going to have some kind of a scale evaluating whatever you are observing. And you're going to have certain questions that as the observer you need to respond to. And you would want both raters to rate the same behavior in the same manner. And the way we're going to measure inter-rater reliability is very easy. So you're going to have the total of number of agreements, okay? So let's just say you were observing a mother and a child behind a glass window and you want to see how affectionate the mother is with the child. So maybe you had a scenario where, for example, the mother is sitting in a room and then her child comes into the room and is a crying child. Then you want to see how fast the mother can actually soothe the baby and maybe like make it to stop crying. Okay, and you're going to have a list of items that you need to check off, like, for example, how the mother is, the posture, facial expression. Is she smiling? Is she too serious? How fast is she reaching out to the child? And you're going to have a checklist of items. So let's just say that you and your coworker, you checked 9 out of the 10 items that you had in your scale. So in this particular case, 9 out of 10, you're going to have a zero point 0.9 inter-rater reliability, which is actually a very high score to have. We want probably the inter-rater reliability to be higher than 6, I would say. 6 is kind of low, but hopefully above 8 would be optimal. Now, keep in mind that inter-rater reliability can get a little bit tricky depending on the type of research you're doing. Okay, so if it's traditional quantitative type of analysis, most likely you're not going to have to worry so much about inter-rater reliability, especially if you're, like, for example, using an online survey where everybody gets the same questions and you're having a computer essentially collecting the answers, the data. Um, in comparison, for example, with people surveying. So you might have, say, multiple people surveying or interviewing participants, and even the attitude, how interviewers talk and interact with a participant, that can affect responses, right? So there's a lot of training that goes into interviewing people in order to, I guess, be as consistent as possible, not to be able to bias our participants. This way, at the end of the day, we can have a very high inter-rater reliability. So in overall, how do we improve reliability? How do we manage to have a really strong, reliable data? Okay. First of all, we need to have some kind of a standardization project process where we have very clear instructions as to how we do things. So there's no discrepancy, and not one researcher does A and another researcher does B. So we need to have very clear rules as to how things are going to be done. We need to have a large sample. Okay, large samples is great, but again, the larger the sample, the more difficult to obtain it, and also the more expensive the research will be. So it's not always possible, but essentially, depending the type of research we are going to conduct, a large sample is key. We need to sometimes pilot our questions to make sure that they're clear. By piloting our questions, we can ensure that what we think is clear, other people think that as well. Essentially, if we see that certain items are not performing well, very well, you have to go back to the drawing board. When we design a test, right, as an instructor, we want to make a test that is not too easy. So, the idea is to challenge your people, your students. You want them to think, right, or your participants. You don't want to make it so difficult that becomes overwhelming. You want to find like a happy medium. Yes, you're going to have some difficult questions depending what you're trying to gain out of it. You're going to have some easy ones, but you definitely do not want to go to the extremes because most likely you're going to lose a lot of participants this way. And of course, you want to make sure that, especially when you're having multiple forms of interviewing people or collecting data, you want to make sure that there's no other external variables that affecting the performance of your participants. Okay, so for example, maybe you're testing some kind of a, I don't know, like a magic pill that makes you run faster. The last thing you would want to do is like maybe be inside a very hot room that would affect people's performance. Likewise, imagine walking into a classroom that is very stuffy and extremely hot, and you're in there with another 50, 60 people and you're trying to take it test. So you want to actually keep the external variables to a minimum. This way you can try to get to that true score and observed score to be as close to being equal as possible. Validity. So validity, when you think about validity, I want you to think accuracy, okay? And that's why I put this little picture here. So here, it's not about being consistent so much as about being accurate, okay? Because by being accurate, we can make useful, appropriate, and meaningful inferences from our data set. Now, validity also comes in different flavors. So we have content validity, criterion validity, and construct validity. As we're going to see, construct is the most difficult one to obtain. Content validity, as the word implies, is like if your survey, if your test is actually measuring what is supposed to measure. For example, when I'm putting your statistics midterm exam together, I want to measure your knowledge in beginner statistics. So essentially, I need to capture those first 7 chapters, right? So I want to make sure that you guys know enough about descriptive statistics. So I wouldn't be throwing questions there, let's just say, as I'm saying here, about dog sweaters, because apparently this is not what you were taught all this time. Meanwhile, I'm aware that sometimes in surveys, people throw random questions there simply to see if people are paying attention, or they simply like responding the same answer out of habit just to get it over with. So that is a technique that psychologists use, but for the most part, especially when it comes to testing students, you want to make sure that the content of your questions, right, is such that it's truly capturing what you are hoping to capture. So how do you establish content validity? You're going to need to consult with your experts, so whatever that may be. So apparently, a statistics course should be designed, or a test should be designed by a statistics professor, right? A dog sweater, how to knit dog sweaters should go to a specialist, right? So the idea is find the expert on that field and consult with them and make sure that the way you're asking the questions and your questions is actually capturing what you're hoping you want to. Criterion validity, that is an interesting one. And criterion validity is also comes in, we separate it in concurrent criterion validity and predicted validity. Concurrent is a precursor for predictive validity. And the idea is, does the test accurately reflect a set of abilities? And here's the key term, a set of abilities in a current or future setting. For example, GRE scores. You probably are aware that if you want to apply for a graduate degree, right, for a master's or a PhD, you need to have a GRE score. The idea is of it behind the GRE exam is that students are prepared to enter graduate school. They have what it takes. They have the knowledge, you have the perseverance to actually pursue a graduate degree. At least that's what they tell you. So a lot of schools pay attention to how high is your GRE score. For example, in some like chemistry schools, public health, for example, they want a very high GRE scores. A high GRE score essentially tells the school that you are going to be a successful graduate student. Another example of concurrent validity would be having medical school students. So let's just say, there's a cohort of students that they pretty much finish their studies as doctors and you're getting ready to release them so they will become professionals. You are hoping, right, that the final exam that you will give them will prepare them and will capture that these individuals are ready to go out there and treat people. So apparently every doctor has a mentor, and the mentor will evaluate them, and then you can also have some kind of an expert in the field evaluate them as well, and hopefully If you correlate those two evaluations between their mentors, which give a thumbs up that yes, this person is ready to come out and be a doctor, and the other expert in the field that maybe is not very familiar with that individual, so maybe they had to give another test, and they also performed as well. So they both examine, you correlate the two, and they both should provide you with a very high score, okay? So if you don't, if there's a discrepancy between the two scores, apparently your concurrent validity is very low. Now, looking into the future in the same example to understand the difference between predictive validity. So, for example, after those kids were released very successfully, they tested really well, and you think, yes, this will be very successful doctor. Maybe you go and you find them 10 years from now. So back then they scored really high. Everybody said, yes, these people are ready to become very successful doctor. Now, 10 years later, you go and you're trying to find them and you see, do they have successful practices? If they do, then that means whatever test you gave them years ago, it was a good predictor of their future success. Okay? So apparently, your previous validity measure predicted also that these people would be very successful. So predicted validity has to do is how well your your criterion validity was able to actually make inferences about the future. Construct validity. So what is construct validity? I told you this one is the toughest one out of all. So this is a way that we establish that the overall test is accurately measuring a specific construct. So here you're talking about if all the questions on that survey all measure what they're supposed to be measuring. So let's take an example. Aggression. How would you measure aggression? Aggression is a construct and consists of variables such as inappropriate touching, violence, lack of successful interaction, etc. These constructs are generated by some theoretical position that the researcher assumes. The researcher can also add to it by proposing that individuals who are aggressive are more likely to have issues with law enforcement. So you have an observational tool that measures aggression, and you would expect that the items in your scale that measure high aggression are also scoring high, and there are no items that contradict your assumptions. Okay, so you want kind of like consistency among your different measures of aggression. Okay, another example, let's say now you want to measure happiness. How do you measure happiness? Apparently, the people who are happy exhibit certain qualities, maybe smiling, being positive, okay, having kind of like a lively attitude. So you would expect that people who score high to score high in all those elements, okay? So if in one of those contracts they score low, it kind of contradicts everything else that you're asking. So you have to look back to your scale and say, okay, is this element here truly measures happiness because somehow it does not align with everything else that I'm having on this particular scale. Reliability versus validity, which is better? Well, this is a tough question. The truth is that you need both. But there is a possibility that you can have a very reliable test that is highly inaccurate. That is not good. On the other side, okay, if you have an accurate test, a valid test, most likely it's going to be reliable, not always, but for the most part, we need both. Every time we design a survey, every time we design a test, we want it to be reliable, which means you need to have some kind of stability over time, right? And you want to make sure that your test is measuring what you designed it to measure. And that is all. Hopefully this was helpful. Let me know if you have any questions. Have a good one.